check certain things from this regression model. So this one is the between regression. Now let's come to the fixed effect regression model. So fixed effect regression model, command one be the same. Instead of B, we type FE. And when we do this, this gives us the fixed effect regression result. And R square here you can see we are getting R square, within R square, between R square, oval over R square. Below that you are getting a correlation coefficient value. So correlation UI XB. So and here the correlation and this correlation coefficient value is positive. That means the error term is related with the any of the explanatory variable. Here since you are using only one explanatory variable, so here error term is related with the explanatory variable. And when that is the case, we get a violation of one of the assumption of linear regression model. And in that case, regression model suffer with the problem of endogeneity. So when we do fixed regression model, and fixed regression model is an appropriate model only the case when there is a endogeneity problem. Number of observations, the total number of observation, number of cross-sectional is 121. Observation per group is also given here. So that any the
Sir, it's XT, REG, independent variable, and then and then dependent variable, or
no, dependent variable. First we write dependent variable, then independent variable. So the same and the same sequence you use for the linear regression model also. And for every regression model, first variable is the dependent variable. So per observation per group is the number of, sorry, this one is the time period. So time period is in our case for 24 years. So minimum and average maximum is the same.
sir, is there any particular reason why we use first dependent and then independent, or it's a norm?
It's a norm.
Okay.
Because when you write our regression, the left side variable is the dependent variable. होता है ना?
Yes, sir. Yeah.
So we use the same principle here. The left side variable is the dependent variable.
Okay, sir.
So F statistics, again we are getting a statistically significant, which show the overall fit of the model, and coefficient value of log of GDP and intercept are also statistically significant. For the coefficient value of log of GDP, if you compare this one with our fixed effect least square domain variable regression result, then we get the same coefficient. So look here, 1.4471. Standard error T statistics. We can also compare that. Okay, the standard error is 0.15, T statistics 13.19. So where this here. So T statistics and standard error are different, but the coefficient value are same. T35, okay, there. No, sorry, everything is same. Sorry, I missed that. Everything is same. So same coefficient value, same standard error, same T statistics. For the log of GDP, fixed effect model and fixed effect least square dummy variable regression result give us the same result. Below that, we are having a sigma U, sigma E, and the rho. So these are relating with the error terms, okay? And for explaining this, I to write and required to write a regression equation, which is not possible at this point of time, but you can follow any standard textbook. Of course, It is given in Ulrich's cross-section panel data econometrics book that I follow for teaching at MA and PhD level. So it is clearly written there. You also have a look on Kevran and Trivedi microeconometrics or microeconometrics using Stata or any other standard textbook at that level. You can get an idea about the sigma U, sigma E, and rho. Microeconometrics using Stata by Kevran and Trivedi also has good dealing with all these terms. So you can have a look. In my do file also I have written a little bit about it, if I remember correctly. Yeah. So you can have a look from there also. And a referring book one is the best idea instead of referring my do file, because and in do file I mentioned all these points as per my convenience. Okay. And of course the details are given in the book only. So now let's move to the random effect. So for random effect, instead of FE, we type RE. Instead of FE, we type RE. And when we enter, we get the result. And look here, apart from others, if you have a look onto the correlation between error term and explanatory variable, here it is 0. And in bracket, it is written here assumed. So when we assume that there is no endogeneity problem, okay, only then we can estimate random effect model. In presence of endogeneity, random effect model give us the biased and inconsistent estimates, as like panel data regression model give, pooled regression model give us. Again, I am repeating, in presence of endogeneity, random effect model give us the biased and inconsistent estimates. Random effect model give us the correct result or only in a case when there is no endogeneity problem. There is a test for making a choice between random effect model and fixed effect model. And that test is called a Hausman test. So for Hausman test, what we do? First, we estimate fixed effect model. Okay. And we store the result of fixed effect model by typing estimate store fixed. Okay. And then we estimate the random effect model. So, sorry, random, not coming. Random effect model and store the results of random effect model. So using this command, estimate store random. Are you doing along with me?
Yes, sir.
And after then we run Hausman test. So for running a Hausman test, we type Hausman and then fixed and random. Okay. We can also add, after giving comma, sigma more. Okay. And sigma more, so sigma more and enter. And here we see the null hypothesis of Hausman test is rejected. And what is the null hypothesis? Difference in coefficients not symmetric. Okay. In a simple language, coefficient value.
It's showing that estimate result is not found.
Pardon?
It's showing that result is not found.
Result is not found.
R111 one error.
Are you using with the my data? Are you using my data? Or
Yes, sir. Same data.
what about the others? Are they getting the result?
So for which part?
Houseman part.
Yes, sir. We got the result. I got the result.
Yeah. Okay. So check what is problem in your case. Let me explain this. So null hypothesis is written here, difference in coefficient value not systematic. In a simple language, we can read it as there is no systematic differences in coefficient value from the random effect model and fixed effect model. There is no systematic difference in coefficient value of random effect model and fixed effect model. And if that is rejected, that means there is a systematic difference in coefficient value of random effect model and fixed effect model. And if this, when null hypothesis is rejected, you use fixed effect model. So we use fixed effect model. And one who is facing no coefficient in common, that person has run two separate regressions. And that means that person has run using different independent variable. So in one case, probably GDP is the independent variable. Other case, it is log total serial consumption is the independent variable. So check fixed effect and random effect model, and then you rerun this command. It's a remagen. And for this, for Shrey, probably you missed storing the result, and that's why you are getting this particular message, estimation result fixed not found. So please do that, and then after you run this command.
Store as an estimate store random.
Estimate, and for random you do that, estimate stay random. For fixed you do the estimate store fixed.
Okay. Okay.
So if in Houseman test, if null hypothesis is rejected, then we will use fixed effect.
Fixed effect, yeah.
Oh.
Rejection of null hypothesis of Houseman test also indicate that there is a presence of unobserved cross-sectional heterogeneity, and because of that, error term is correlated with any of the independent variable.
So can you please repeat it?
And this test is called the indirect test of testing endogeneity. So when null hypothesis is rejected, This means that there is an unobserved cross-sectional heterogeneity, and due to the presence of unobserved cross-sectional heterogeneity, error term is correlated with any of the explanatory variable. And the logic comes out from the theory. We know from the theory that all the important and all the explanatory variables that we missed out incorporating in the regression result, effect of that captured by the error term. So the same is case here, since we missed accounting unobserved cross-sectional heterogeneity, then the effect of that captured by the error term, and in a case if the unobserved cross-sectional heterogeneity related with any of the explanatory variable, error term is related with the explanatory variable. And that is the case of that is the case of endogeneity. So whenever we have rejection of null hypothesis of Hosmond test, we use fixed effect, no doubt. Sometimes what happens, we do not get rejection of null hypothesis, but even after then, we use fixed effect model. And because of that reason, Hosmond test is not considered as a sufficient test for deciding between fixed effect model and random effect model. Listen me carefully again. I am saying when we have rejection of null hypothesis, we use fixed effect model. So no doubt there. Doubt arises when we do not have rejection of null hypothesis. So one may say when null hypothesis is not rejected, then we can use random effect model. Because Hosmond test is mainly a test between the fixed effect and random effect model. So when it is rejected, we can use fixed effect model. When it is not rejected, the obvious choice is the random effect model. But I am saying when we have a rejection of null hypothesis, when we do not have a rejection of null hypothesis of Hosmond test, in a certain condition or in certain cases, okay, we can use fixed effect, otherwise the random effect. And those cases are following. The first one is when our cross-sectional unit is country, any large geographical unit, state, district of a state, then in that case, we always use fixed effect. Country, large geographical unit, state, and districts of a state. Then you can use fixed effect. Always. In a district case, we may sometimes use random effect, but for the other country, large geographical unit, state, particularly the Indian states, where you find a very huge differences. So in that case, we use fixed effect model. For random effect, if we are sure that if we are sure that the cross-sectional unit is coming from a large population, in that case we can use random effect model. in that case, we can use random effect model. So in this particular case, here our cross-sectional unit is country.
So can you repeat for the the random effect?
For a random effect model, if we are sure that the cross-sectional unit is coming out from the large sample, sorry, large populations, okay? Sample is the cross-sectional unit. In that case, we can use a random effect model. In that case, we use random effect model. In our case, the cross-sectional unit is country, is spread across the world, and we know that these countries are different, substantially different from one another. So there is a huge heterogeneity across the country. So in our case, we always use the fixed effect. So even though we get a non-rejection of null hypothesis, we use fixed effect model. I learned this lesson from the publication of my first paper, which was published in 2013 in EPW. And I remember when I ran that regression, null hypothesis was not rejected. And on basis of that, I used random effect model. When that paper got published, okay, I got a comment from one of the MIT professor. Okay. And he guided me, okay, even though you have used random effect model, but in your case, it sounds inappropriate for using random effect model, though he did not counter with my results. Okay, he mentioned that all your results are valid for whatever for you are arguing with this particular result that are correct, and possibly that will hold when we run the fixed effect model also. But for making a choice between the fixed effect and random effect model, he simply mentioned that random effect Hosman test is not a sufficient test for checking fixed effect and between fixed effect and random effect model. And I noticed his point, okay. And when I explored the literature, I found that that person was right. He was a professor at MIT, obviously. Okay, I was at that time just a young researcher. So, and then I learned later. I got this one in Gujarati also. Okay, Damodar and Gujarati. Though Gujarati did not mention anywhere, can't consider Hosman test is a sufficient condition. Okay. Even none of the textbook mention this particular thing, but since I learned this lesson from MIT professor, so every time I mention when I teach this to the students. One objective of mentioning every time, it is a regard and my regard to that professor. Okay, I learned this particular part from him only. So any doubt till now?
Sir, actually, जो last वाला part था वो थोड़ा doubtful है.
कौन सा last वाला part?
कि Hosman test कि when can we use fixed effect and when can we use random effect model? जो the two cases which you have taught.
फर्स्ट, जब नल हाइपोथेसिस रिजेक्ट हो जाएगा तब हम फिक्स इफेक्ट करेंगे ही करेंगे, उसमें कोई डाउट ही नहीं है. कुछ भी हो, अगर नॉन रिजेक्ट हो रहा है तो हम फिक्स इफेक्ट करेंगे. डन.
Yes.
सेकेंड केस है जब नल हाइपोथेसिस रिजेक्ट नहीं होगा, तो उस केस में क्या करेंगे कि कभी हम फिक्स इफेक्ट करेंगे, कभी रैंडम इफेक्ट करेंगे. ठीक है। कब फिक्स इफेक्ट करेंगे ये समझना जरूरी है। तो जब भी हमारा क्रॉस सेक्शनल यूनिट कंट्री हो, कोई बड़ा जोग्राफिकल यूनिट हो, जैसे कि एशिया, फिर एशिया हो ले लिए, अफ्रीका ले लिए, ईस्ट एशिया ले लिए, लैटिन अमेरिका ले लिए, तो ये बड़ा बड़ा जोग्राफिकल यूनिट है। इंडिया इज इटसेल्फ अ बिग जोग्राफिकल यूनिट। ओके, तो लार्ज जोग्राफिकल यूनिट होगा करीब विद इन भी इंडिया। अगर हम लार्ज जोग्राफिकल यूनिट लेते हैं तो फिक्स इफेक्ट करेंगे। स्टेट्स अगर लेते हैं तो इंडिया का अगर स्टेट्स अगर हम देखें तो हेट्रोजिनिटी बहुत ज़्यादा है, ऑलमोस्ट इन एवरी टर्म। कोई भी इंडिकेटर्स आप ले लीजिए, यू कैन सी देयर इज ह्यूज हेट्रोजिनिटी अक्रॉस इंडिया, अक्रॉस स्टेट। सो उस केस में भी हम फिक्स इफेक्ट करेंगे। डिस्ट्रिक्ट्स को लेकर मैं बहुत डिफिनिटिव स्टेटमेंट नहीं दे रहा हूँ। इट आल्सो डिपेंड अपॉन स्टेट टू स्टेट कि किस स्टेट्स का डिस्ट्रिक्ट ले रहे हैं। ऑफ कोर्स अगर ऑल इंडिया डिस्ट्रिक्ट एस्टिमेशन है तब तो फिक्स इफेक्ट ही होगा, लेकिन अगर कोई पर्टिकुलर स्टेट्स का होगा तो प्रोबब्ली यू डू नॉट फाइंड मच वेरिएशन देयर। सो इन दैट केस यू मे यूज रैंडम इफेक्ट एंड फिक्स इफेक्ट। दूसरे सारे केसेस के लिए यानी जब रैंडम इफेक्ट तब हम करेंगे जब हमको यानी हम श्योर रहे होंगे, हमको लगेगा कि जो ये क्रॉस सेक्शनल जो यूनिट है एक बड़े से पॉपुलेशन से आ रहा है, दैट इन इट इज कमिंग आउट फ्रॉम द रैंडम सिलेक्शन और some sampling out by using some sampling procedure, and it's a part of the large population coming out from the large population। अगर हम इस पे ये सिक्योरिटी हमें लगेगा तो हम ये रैंडम इफेक्ट करेंगे। इन
Sir,
केस
so
नॉन
our
रिजेक्शन
cities,
आरसीटी
जो होते हैं उसमें हम आरई यूज करते हैं।
नहीं, आरसीटी रैंडमाइज कंट्रोल ट्रायल आई एम टॉकिंग अबाउट।
या
नहीं, उसमें पैनल करने की जरूरत पड़ती है, कभी किया है आपने पैनल?
आप नो सर, आई डोंट नो, आई एम आस्किंग।
आरसीटी में पैनल होता ही नहीं है।
ओके।
पैनल डेटा नहीं, one can get the panel data also, but for that one need to observe the household over a period of time। I don't know कि आरसीटी में पैनल नहीं हो सकता है, बट आरसीटी क्रॉस सेक्शन में भी बहुत अच्छा रिजल्ट देता है।
ओके ओके
ओके, तो आरसीटी के केस में प्रॉब्लम ये जो रैंडम इफेक्ट फिक्स इफेक्ट उतना अप्रोप्रिएट नहीं है। बट इफ यू अगेन आई एम सेइंग इफ यू आर श्योर दैट कि and sample is coming out from a large population, okay, then you can of course do random effect model, no doubt।
ओके सर।
So that is for the random effect and fixed effect model।
Can we do least square dummy variable model with the connect it with the fixed effect and random effect also?
हाँ,
Or we do a
fixed
simply
effect
regression?
least square variable is connected with the fixed effect model, and both of the model give us the same result। There are
Okay.
certain drawbacks of fixed effect least square dummy variable regression result, and because of that we do not do that। And one drawback is that there is a chance of losing substantial degree of freedom because of large cross-sectional unit। The second one, you can say there is a chance of getting multi-causality also।
Okay.
So these two problem are major problem, and the others are of course the result we get in the form are not looks nice, okay, because we get a coefficient value for each of the country, okay, and we also do not get a correct any desired R statistic, R square statistics, because I shown you R square in that case was 9.95, and if you look and if you match the serial consumption theory with the income, so for the poor you can say that income determine 95% variation in the consumption, but for the rich, for the middle income, of course not everyone is spending entire money on the consumption only, and particularly on the cereal consumption. It's sound untrue, okay, even so that's right। And in fixed effect case, we get a desired result. Here you can say only 59% of variation in consumption explained by the income. Okay. Within variation is only 30%. For a particular country, the within variation is only 30. Between variation is larger. Of course, I'm not covering the theory here. The first of all, I want to make you clear. Okay. For the theory, I'm suggesting two reference reading. One is the by the Ulrich cross-sectional and panel data econometrics, and other one by the Kemler and Trivedi. And these are the two best book. Okay, the best. Of course, I'm finding difficult to say which one is the better. For some part, Ulrich is the best, and for some part, Kemler and Trivedi is the best. So overall, these two books, if you go through these two books, you will become a you can acquire a good knowledge on the econometrics. Okay. So
I have a question.
yeah.
Let's say I'm working on Indian states and the Hosman test says that I should go with random effect model. And as you mentioned that theories don't support that, we should not use random effect model. So how should I write this thing in my paper?
Write my statement.
Okay.
Yeah. Side Gujarati.
Okay, side. But in Gujarati also you said it's not mentioned that that REM should not.
That I was making. Okay. The idea of that point is there. Okay. So you can cite Gujarati. You can cite Ulrich. Okay.
Okay. Thank you, sir.
In my case, there is one more paper. If I mention the same there, then you can cite that paper. That paper was published in Social Scientist.
Okay.
Yeah. And in that, I used a fixed regression. But if I mention this particular point there, you can cite that. If not, then you can cite Ulrich, Cameron, and Trivedi or Gujarati, whatever.
So can you please mention that paper name?
The paper one is title of the paper, I think, explaining calorie consumption puzzle.
Okay.
And evidence from the NSSO data, something like that. Okay.
Yeah, okay, sir.
You just Google my name and
Sure,
social
sir.
scientist. Okay, you get
Okay.
the paper.
Okay, sir. Thank you.
Okay, so
Krishna sir, so you are
yeah.
talking about microeconometrics by Cameron and Trivedi? Or?
Yeah, microeconometrics. Yeah.
Okay, thank you.
To get a command on econometrics, these two are the best book. Okay, so
Gujarati.
Gujarati for the basic. Because you do from Gujarati, you do not get the confidence. Confidence you get only reading these two along with one more book. That one is by the Grith. Okay, econometric analysis, microeconometrics, mathematical applications, and this cross section and panel data econometrics. They give you the confidence. Okay, confidence being applied econometricians, not becoming an expert in econometrics theory, but you can become an expert in applied econometrics. Okay. In cross-sectional and panel data particularly. Of course, for time series, Dr. Ganesh Maji will tell you more reference reading, and he is the knowledgeful person for the time series econometrics. I remember even long back, even I had a doubt in the time series econometrics, and for the I consulted Ganesh only. Okay, you are the batchmate, so we did our PhD together from a different center. Okay. Anyway, any doubt from here? Any more doubt?
Sir, how to find out this endogeneity exactly, whether it is there or not?
The indirect test one is the Houseman test. Indirect test one is the Houseman test. The Houseman test. Other one is you can say you can estimate the residuals and take residuals as a dependent variable and other explanatory variable as an independent variable. Run that regression. If you get the coefficient value statistically significant, that means there is an endogeneity problem. Okay, let's move further. And now we are going to do a testing for the random effect model. Okay. And for that, we use Bruce-Pagan language multiplier test. And the command for that, first we estimate random effect model. And after estimating the random effect model, we use this test, XT test 0. XT test 0, this one. And here we are getting no rejection of null hypothesis. And the null hypothesis of Lagrange multiplier test is that variance across entities is 0. That means there is no significant difference across cross-sectional unit. There is no significant difference across cross-sectional unit. And the null hypothesis is rejected here. That means there is significant difference across the cross-sectional unit. That means there is a presence of unobserved cross-sectional heterogeneity. There is a presence of unobserved cross-sectional heterogeneity. Just a minute, a call is coming from my office. I am joining back. हेलो, हाँ, गुड आफ्टरनून सुनीता, बताइए। हाँ, मीटिंग हो गई है, मिनट्स तैयार करनी है तो
Sir, please unmute yourself. Krishna sir. You are muted.
yeah, done. Yeah, can you hear me?
Yes,
Can you
we
hear
can
me?
hear you. We can
Yeah,
hear you now.
Okay. So thanks to the admin for muting me. I was not getting the options. Okay, anyway, language multiplier test. Okay, so we do this test for checking whether there is a presence of random effect or not. Okay. So null hypothesis and a rejection of the null hypothesis means there is a presence of random effect. So in a case there is a no endogeneity problem, we go ahead with the random effect. Okay. If this null hypothesis was not rejected and there is no presence of endogeneity, then we go with the pooled regression result. So you can say this test is a test between the pooled and random effect. So rejection of null hypothesis means we can use random effect, otherwise pooled regression, given that there is a no endogeneity problem. We can also do the testing for time effect. So for testing the time effect, we run regression, and this time we're running a simple linear regression, ln T serial and this ln GDP. Okay, and then I year and enter. And okay, so we can see here the some of the error coefficient value are statistically significant. I think none of the error coefficient value is statistically significant. So I mistakenly read the last one, which one is the coefficient value of constant. Of course, we can test this one. Test parm is the command. फिर underscore I select from here. Underscore I here. And do not put and put a star. Star is for all here and enter. So it is a simultaneous testing for all the error coefficient value. So it's a standard test, and here you get the non-rejection of null hypothesis. That means the error variable is not statistically significant. So it is a testing for the time effect. I don't know how many of you heard about the one-way panel regression result and two-way panel. So sometimes it is used with a fixed effect, one-way fixed effect, two-way fixed effect. One-way, two-way. So when we go without time dummy variable, then that called a one-way panel regression or one-way fixed effect result. If you are using a fixed effect, so one-way fixed effect. I'm not getting the name of the author who has used this particular term in his book. And he's a famous author in econometrics subject. Okay, anyway, sometimes happen. So one-way fixed effect when you do not have a time dummy in the model, and two-way when we have a time dummy. So two-way means when we it's more true with the fixed effect model, because in a fixed effect model we account for the cross-sectional heterogeneity. So without time dummy, that is the one-way fixed effect model, and with the time dummy, that model called a two-way fixed effect model. So do not confuse. So we are not going to use two-way because here coefficient value are statistically insignificant. So two-way effect model is not an appropriate model for us. So, but this way we can use the time effect. We can also use the do the testing for the fixed effect, and for that, again we can run a simple linear regression model, ln GDP, and then IE country code. Because country code is our cross-sectional unit, and if you enter, we get the result. So same as like the fixed effect model, fixed effect least square dummy variable regression model. And here you can do a testing. So we can use the simple hypothesis testing command in this case, test, and select I country, I go only, and then put a star here. It's I country, so not running by you enter country code and then star. Say I country code not getting. CO event TRI country code. So anyway, it's not running. So what we do, we can choose this one, I country 4, I country 8, and so on. So after this, you can select all the variable. That means all the dummy variable that is going till should be, I think that has generated 2 times. So it's creating an issue here because our cross-sectional unit is only 122. So 121 dummy would come here. So check 121 is ending here. So you can take this one to your command window, and then after you enter, we get the result. So it is rejected. That means we are having a fixed effect. So you can select all country dummy and do the simultaneous testing, and we get the F statistics, and that shows and that shows here countries are statistically significant. Sorry, I have selected only 62. So I think it's required to select the all country. Okay, all country there. Are you getting me? Are you getting me?
ये कृष्णा सर थोड़ा रिपीट कीजिए, आई मिस्ड इट.
I'm saying we can also check the fixed effect, whether there is a fixed effect or not. And for that, what we do, we run a simple linear regression model, this one. Okay. So we first estimate this one. And after this, we can do the testing for all cross-sectional unit damage. So we type test. Test is a command for doing an hypothesis testing. Then we select all cross-sectional damage that are in your variable window. So from here, so all, so you can select all. So when we, after selecting those variable, click right and bring those to the command window. Send variable list to the command window, and then you enter. Okay, and we get the F statistics. So this one is for testing fixed effect, and this indicate us a fixed if pooled regression result is not appropriate. Okay. Then you have to make a choice between random and fixed effect. Since you have already done a Hausman test, and we know that in our case fixed effect model is appropriate. But these are the tests that we generally do when we work with the panel data regression model. Okay. Similarly, there is a test for serial correlation also, and we can do the test for that. There is a test for normality also. We can do the test for that. So, but since we have made a choice of using fixed effect model on basis of Hausman test, so let's use the fixed effect model. So this one we call our selected regression model. I am using this selected word consciously, not using the final regression model. So the appropriate, or you can say the appropriate regression model is the fixed effect model in our case. Why? Because Hausman test is rejected. So we made a choice of fixed effect model. We have also seen that there is a cross-sectional heterogeneity. Okay. So we run fixed effect model. So this one is our appropriate model in this case. After selecting, after doing Hausman test, we do the diagnosis testing. So here we do the diagnostic testing, because these are the important tests that we must do after running or after estimating fixed effect model. So first we do for the test for heteroscedasticity. So for heteroscedasticity, after running this regression model, just type xt test 3, xt test 3, and this will give you the result for the heteroscedasticity. And null hypothesis is again there is a no heteroscedasticity, and we get a rejection of null hypothesis. That means there is a heteroscedasticity problem. We also do a testing for the autocorrelation, and for the autocorrelation, after running the fixed effect model, we type, so run fixed effect model, and then we type this command xt, so xt serial, then log of total serial and log of GTP, and enter. And again the null, so it's a oldest test for autocorrelation in panel data, and null hypothesis is no autocorrelation, no first order autocorrelation, and we also get a rejection of null hypothesis. That means there is a autocorrelation. So till now we have seen that there is a problem of heteroscedasticity and problem of
XT serial
autocorrelation.
is for what? Autocorrelation.
Autocorrelation, yeah.
Okay, sir.
So there is a problem of heteroscedasticity and autocorrelation. We can also do the testing for the normality. Okay, so normality test we do when we use the random effect model. So for that, first we estimate the random effect model, and then we use this command xt sk test. So it's a skewness Kurzgesagt test. So that we are getting skewness of E, kurtosis of E, skewness, and then kurtosis of U. I'm not interpreting this one for you because I have, in that case I have to explain what that means, E and U. And you can easily get all these things from the theory when we go through the theory. Okay. And of course, explaining this required for a writing a regression, and that take our time. So null hypothesis is again rejected here in case of E. In case of U, it is accepted. So U is a composite error term, and E is, we can say, individual error term. So joint test for normality. So we can say that, can say here that there is a non-normality issue with the error term of E. But you again with the composite error term, there is a no non-normality issue. So finally we can say that there is a no non-normality issue. Okay. And even this one is a large sample data. So with a large sample, there is hardly any problem of the non-normality. But a more important test that we require to do with the fixed effect model, that one is for the testing for the cross-sectional dependence. That test also called the test for the contemporaneous correlations. And the test that we are going to use, we can use both in case of balanced and unbalanced panel data. The other test is also valid for the balanced and unbalanced, but since till now I haven't worked with the unbalanced panel data, never get opportunity to work with the unbalanced panel data. Okay. So estimate the fixed effect model again, and then after we do the testing for the cross-sectional dependence or contemporaneous autocorrelation. Contemporaneous autocorrelation we define in a sense given error term of country I in time t is correlated with the error term of country G at time t. So error term of country I in time t is correlated with the error term in country J at time t. And when we have a contemporaneous autocorrelation, in that case, we get a bias and inconsistent estimate. So the test for this one is one called a Pisaran test. Pisaran test. And for Pisaran, the command one is XT, Pisaran, ABS, and enter. Pisaran, ABS. So it's a Pisaran test of cross-sectional independence, and probability value is 1.96. Null hypothesis is this test. Okay, there is no cross-sectional dependence. Okay. There is no cross-sectional dependence. And since probability value is 1.96, so we do not reject the null hypothesis. So there is no cross-sectional and no cross-sectional dependence, or you can say no contemporaneous autocorrelation. In our case, there is another test that we call the freeze test. So for freeze test, we just type XTCST and then freeze and enter. So it takes some time to give you the result. There is one more test that we call Friedman test. Okay. And in this test, we are rejecting our null hypothesis. So freeze test basically reject the null hypothesis of no cross-sectional dependence. Okay, because critical value here is 23.27, and that is more than the critical value of freeze Q distribution. There is another test that we call the Friedman test, and these all tests we do it in a different circumstances. Okay. More on it is given in there is one article by the Higgs, and for other reference reading, I think Cameron and Tirvedi we can also find all these. So again here the Friedman test reject the do not reject the null hypothesis. So ultimately we can conclude here because two tests are rejecting, two tests are not rejecting, one is rejecting. So we can see here that there is no cross-sectional and dependence. We can also go ahead with of course there is any theory behind it, which test is appropriate in what circumstances. So that I am not covering. Okay. The reference reading, as I suggested you, that one is the one Higgs paper for it, and Cameron and Tirvedi book. Any doubt till now?
Hello, yes, sir.
So, yeah.
Am I audible, sir?
Yes.
Sir, my codes XT, CDS, all these codes could not run whatever test you have told. I could not run all these tests from XT test 3. Is there any package or anything else that I have to download?
Yeah, you have to download the command in that case. So XT3 case, again, we have to SSC install XT3 and XTCST. If not also not working, then you please download this one. SSC install. So downloading any command, command line is this SSC install, and then you write the command name. Okay.
Okay, thank you, sir.
XTCST. Okay. If that has already been installed, then install. Okay. Then you type.
Okay.
Then you get the message accordingly. So it's the following file already exists and are different. Okay.
I can't install XT serial.
We can also download XT serial using SSC install first. Okay. So everything, if say a command not found, then in that case first we install that command. Okay. Any other doubt? Yes.
Sir, I can't
Sir, I
install XT serial. Like it's showing that not found. If I'm trying to install it.
Okay, just a minute. Install XT serial. Install SSC install. So SSC install is not found at SSC. So it's just type this one, type search SSC XT serial, and then you find it. Probably it moved somewhere else. So you can look here, this page has opened, and if you click onto it, so click on this part ST0039, and from here you can install. Click here to install, that will be installed. Okay. In my case, it is already there. It's a checking and then it will stop. Got it? So try this. So one is the search command. The second one is the find it. So help one is the again important part, like find it XT serial. So this also give you the same result. So search or find it. Sometimes some command are not part of the SSC. Particularly the user written command. So user written command you require to install differently. Okay, got it. Any other doubt?
In my
Sir,
company's data set, the adjusted R square value is around 27%, and the model is good fitted. So should I communicate those results in paper, or
Yeah.
should we trying for
How many observations do you have?
It's 420.
420. Try and check explanatory variable list and check your explanatory variable and be sure that you are not missing any explanatory variable. So that means you have considered explanatory variable that are all the explanatory variable that are suggested in the literature. And after then, if your result coming to 0.27, then that's okay. Okay. Now let's
sir, why don't we run normality test for fixed effect model?
Normality test is not a mandatory test for estimating the regression result when you work with the large sample.
Okay. And for random, we are doing it.
For the random, because random you are assuming that that sample is coming out from a large population. With the fix, we are not making that assumption. We are taking cross-sectional unit as they are there. Okay, so if the world having a 219 country, let's suppose that, then you are taking all 219 countries. So there is no issue of having a selection. And if you check the normality of 290 countries, then you do not get a normality, because countries are different from the one another in all respect. Okay, getting me?
Okay, sir. Yeah.
That's right. Yeah. Anyway, okay. Any other doubt? Okay, now I am sharing an article with you. That is not here. Okay. That one is this one. It's a journal article, Stata journal article. You take a picture. I will also share this one with you. Robust standard error for panel regression with cross-sectional dependence. Okay. You can read this article. Where that has gone to
So can you send the article in the group
Yeah, I will send this one. Okay. So
and also the two names of the books which you mentioned?
yeah, definitely.
Thank you.
Now have a look on this particular page. Okay. And I advise everybody to go through this article. Okay. If you do not get any many things from this article, initially go again and again. Okay. And it is a very important article. Look here, the command are given, stata command, option are given, and then standard error estimates are robust to disturbance being are given, and notes are also given. So when your regression results, panel regression results, only suffer with the heterozygotic problem, then you type an xt regress, then dependent independent variable, and as an option you can use robust for the final regression result. So heterozygosity will remove and we get the correct estimates. When there is a problem of both heterozygosity and autocorrelation, then you can use this cluster option. Okay. When there is a heterozygosity, contemporaneous autocorrelations, and autocorrelation of type AR1, we can use XTGLS command with these options, panel or correlation. And this we can use when n is less than t. That means in case of long panel. So when again we divide panel into two category, long panel, short panel. So long panel when n is less than t, and short panel is when n is greater than t. So in our case, we are using a short panel. Okay, and long panel require a concept of time series econometrics, and because of that reason, I avoided teaching this long panel.
Long panel is when?
N is less than t. Number of cross-sectional is less than time period. XTPSC, again we can use heterozygosity, contemporaneous autocorrelation, and autocorrelation at order 1. Okay. And so large scale panel regression with XTPC take a lot of time. So it takes time to give you result. The best when your regression model suffer with all three problems, heterozygosity, autocorrelation, and contemporaneous autocorrelation at any order, that one is XTSCC. And this article is for it only, XTSCC. So it has a bit literature review, and then at the end, it talk more about the XTSCC command and so. So in my case, if you use the XTSCC, so we can use it like this. So XTSCC and then log total serial, log GDP, and then as a option, moving average, you may type 1. Autoregressive or moving average, anything. Okay. Let's check with the regression. So with the that has gone. And this one. So it is on page number 5. So it's a moving average. So you can use the moving average option if you want to take. Okay. Of course, Ganesh will tell more on this moving average. Sorry, I'm not going to tell anything. So Ganesh will tell about what is this moving average, what is this auto regressive. So if you go with these options, you say MA not allowed. So let's read this one. And then if you go with this option, okay, it remove uh, heteroceracity autocorrelation and contemporaneous autocorrelation problem. Though our model is not suffer with the contemporaneous autocorrelation, you can also use the XTPC command. Oh, sorry, it's a pooled one. Fixed we need to type. So this one is our fixed regression result. Sorry, the earlier one is the pooled one. Okay, so this one is the robust fixed effect regression result. Robust fixed effect regression result. So group variable is country code, maximum like is taken here too. That one is for the moving average. I think that's a default results. So this one is our final regression result. You can interpret this regression result. There are some more resource material are given on the Princeton University website. So if you type panel regression, Princeton University, you get the link for a PPT presentations, okay? And most of the part that I taught you today, particularly the command test, are from that PPT only. And that is really a good PPT. The interpretation of coefficient value, all these statistics are given there. Random effect model is interpreted a little different from the fixed effect, particularly the coefficient value of independent variable. So I advise you to have a look of that PPT. And we also get many more resource material on this data with the linear regression model, non-linear regression model, panel data regression model, time series regression model. So I always find that an university website is a good source for learning econometrics. There is also one more in university website, I think University of California. So again, from there you get a good source material on learning all the softwares and econometrics.
Excuse me, sir.
Pardon?
Hello. Sir, I have one doubt.
Yes.
I just want to ask, what is the use of the Probit pooled regression model? Can you explain?
Probit pooled regression model.
Yes.
A good discussion on it given in the Ulrich cross-section and panel data econometrics. Okay, so basically, as I said, when we require to define our data set as a panel data set. So when we do not do that and do the regressions, so basically we are estimating the pool regression. And in the pool regression, we do not bother about the cross-section heterogeneity, because in that, as I told you, implicitly assume that each observation is independent from the one another. So we do not bother about any interlinkages with within the observations, okay, for a group of country or for a country. So that's why and in that case we just pull out observations and pull all observations together without bothering about their nature, their characteristics and other aspects. And when you use logit or probit model with that data, that called a logit, pool logit and pool probit. But there is a problem with that. That's why I referred you the cross-sectional and panel data regression book. Would be always better to
sir,
use.
Sir, it means when we use pooled, that means we are implicitly assuming that there is no heterogeneity among countries if we are taking countries.
Yeah, you can say that, but in a pool, we also do not bother about many other things. Okay, we also don't bother about the correlations between observations. Like for a one country, if you are having a data from 1990 to 2000, then we can also expect there is a correlation between the observations. Okay, because 1990 is related with the 1991 because of several reasons. Okay. And for many economic variable, you can find a relationship and it's between observations, particularly time. That's the problem with the time series, okay? And that's why you having a evolution of the time series. Time series deal with all such cases because you're having a correlation over a period of time. Autocorrelation you may heard about, okay? So pooled regression result, of course, we can use because several times even you do not bother about many of the problem, and because our target is to get a specific thing. So you can use, but would be better, again I'm suggesting to use panel logic model or panel probit model, or as I think want to read more onto it, then have a look on the oldies cross-section and panel data econometry. Then you decide which one is the better, and if you are using a pooled probit regression model, then what kind of any considerations, okay, you require to take care of. Okay, so you require to be a conscious. You can't just run a regression because you pull the data and you know the logic of probit model. Okay.
So, sir, it's better to use panel probit model than pool probit.
It's always better, but because panel is better than the pool. I just taught you, and
Yes.
why it is better, I also shown you. So it is always, panel is always better, okay. But panel requires some many conditions, and that need to be fulfilled.
Thank you, sir.
Yeah.
Can you please tell your 39th command?
39th is what? This one, yeah.
So when I put that command in my data, it is showing that variable I year star not found.
It's also showing in my case. Test farm, when I run this, test serial run I, and test farm for I think cross-section. Not showing now. Probably before that you estimate this regression result, full regression result, and then you can use this one. Okay, now it is showing. So first we run this regression, and then we estimate this one. Okay. This is a testing for the time effect. Okay, any doubt? 4 has passed, so if you have any doubt, then you ask me. Otherwise, you will. I will end my lecture and hand over to Faraj. Shall I stop sharing my screen?
Yes, sir, I
Last
believe.
one doubt.
Yes.
The last one, the doubt. I have one dummy variable, which is a categorical variable, and I have converted that into dummy. And now, when I regress in the fixed effect model, it shows the problem of collinearity.
Do
So
not
how
use.
to do that?
Then for fixed effect model, do not use any dummy variable.
Okay.
Uh,
Then sir, फिर कैसे पता करें कि इस वेरिएबल का फिक्स इफेक्ट है कि नहीं है? फिक्स
नहीं
इफेक्ट
पता
मॉडल में
नहीं पता लगेगा और ड्रॉबैक्स है फिक्स इफेक्ट मॉडल का.
ओके थैंक यू.
Okay.
Okay, so I believe all the doubts have already been cleared by Dr. Krishna. And I thank you, sir, for your extensive and very clear explanation of panel data models and their use in Stata. I thank you from Dr. Biro's side and my side and side of Christ University Department of Economics that you gave time for these 2 days, and you dealt with all the problems and models related to panel data econometrics. Thank you so much, sir. I believe all the participants must have gained some knowledge over and above what they had before, and their doubts must have already been cleared regarding panel data. So I thank you once again. Thank you so much for being here with us for these 2 days. Thank you, sir.
Okay. Thank you, Faraj. Okay, and I also like to thank all the participants for their interest in my lectures. Okay, they ask very good questions. Okay,
That's very kind of you, sir.
yeah. Okay.
So thank you everyone. Tomorrow we'll be starting with time series, econometrics time series models at the same time, 2 p.m.
Okay, so bye bye, and bye bye to everyone.
Thank you once again, everyone. Good day.
Okay, bye bye.